Okay, so the first one, linear, quadratic, or exponential, you look at the exponent and it's a 2, and that tells you that it's what kind of equation? I have a vote for quadratic. Anybody else? Agree? Good. Yes, when your exponent is a 2, you have a quadratic equation. Okay. The next one, you look at your exponent. The exponent is an x, and that makes it what kind of equation? Eamon says exponential. Anybody else? I see some agreement. Good. So when your exponent is an x, that is an exponential equation. All right. Questions before we go on?
Are you reading that in the section?
Say that again?
Are you reading that in the section?
No, but you can put it on your paper and you can use your paper. Oh, you mean, am I leaving those on the board?
Yeah.
Yes, I am. Can you pull your mask up? Thanks. All right, for each equation, name the transformations from the parent function. So some of you graphed it on Desmos, and that's totally fine. We'll look at the graphs as well. But you can also do it without graphing on Desmos. Whenever it's in the parentheses, it's moving left or right. And did this first graph move left or right from the parent function? Can you guys tell me? Kelly, what did you put? Very good. All right, so because of the x minus 5, the graph shifted right 5. Okay, and then because of the minus 3 here, it shifted which direction? It did shift down, very good. So because of the minus 3, it shifted down 3. Oh, I hate when it does that. It makes me seasick. All right, shift down 3. Okay, and the last transformation is that 2 that's in the front. This one right here. So it would be a reflection if it was a negative. In this case, what is it? It multiplies all your y values by 2. What does that do? It stretches it, right. So it's a vertical stretch of 2. All right, I want to look at that in Desmos as well. So let me pull that up for you. Okay, so the parent was y equals x squared. And then the transformation was y equals 2 times x minus 5, close parentheses, squared, minus 3. All right, so you could look at the vertex to see that it moved right 5 and down 3. And then I can see that it is stretched because the parent function, let me put in some more numbers here. You can change your step to 1 so that you can see more numbers. It might help. I did that up here with the tool. Okay. So the parent function from the vertex, it goes over 1 and up 1. But this function from the vertex, it goes over 1 and up 2. So I can see that there's a stretch of 2. But I also know it just from the equation because I see a 2 right here. So I know that there's a stretch. You guys ready to do the next one? Okay. All right, so for the next one, we have a negative and we have a 3. What did the negative do to the function? It reflected. Yeah, it did reflect. So we had a vertical reflection.
That's what the 2 did?
That's what the negative did, right there. The 2 is part of the parent function. If you check out the parent function on the board, see it's already there.
So whenever it's negative,
Very good. Well summarized. Okay. And then the plus 3, we know that does something. For some of you, when you looked at the graph, you thought, it doesn't look like it's moving 3. It looks like it's moving 1, but it is moving 3, and we'll figure out why in just a minute. Which direction did the graph move? It did go up. And it did go up 3, and I know it didn't look like it, so I'm going to show you how that works. So we had a vertical reflection, and we had up 3. I'm going to leave that there for a second, and then we're going to look back at the Desmos and see if we can figure out why it's up 3. Okay. So my parent function is y equals 2 to the x. And then my transformed was y equals negative 2 to the x. And then plus 3. Okay. So a lot of you were looking at this point here and you said, well, that point only moves up 1. And it does look like that. I get that. We have to think of these in terms of one transformation at a time. So in between these two, we had another one. We had y equals the negative. This is one happened first, the negative. Okay, so we started with the green one. And then we went to the black function here. And you can see now your y-intercept is at negative 1. So we move from negative 1 up 1, 2, 3. And that's why it's a shift of 3 up. Any questions on that? Okay. All right, let me go back to my other screen then. All right, we're going to do domain and range. So your domain, you're going to read it from the left to the right. And your first point here has an x value of what number? It is 0, thanks. And then you continue until you get to your last point on the right, and the x value of this number is how much? It's 3, good. Now, I know we don't see dots. Remember last class we saw some dots, some closed dots, some open dots like that? We don't see any dots. If you don't see dots, you're gonna include the number. And so to include the number, do I use square brackets or parentheses? So the parentheses actually leave it out. The square brackets include it. So we're going to put the square brackets on it, okay?
What do you mean by dots?
So when you missed a class last class, we had some graphs that had like endpoints, like this. And that would explain whether or not we wanted to include the endpoints. But in this case, I don't have any dots at the end, and so I will always include them if I don't see the dots, okay? So you're always going to use those square brackets if you don't see this. Okay.
You do see it.
And if you do see it, then you would change it to parentheses only if it was an open dot. All right, the range does not use exactly the same 2 points. The range starts down here at the bottom. And what's your y value at the bottom? What number is that? It is a negative 1, yep. So we start at negative 1. And then we keep going to the top of the graph, which is all the way up here. And what's your highest y value? 3 is good. Okay, ask a question. Okay. Next one, domain. Your first x value is how much? It is -2, thank you. All right, and then you continue across until you get to your last x value, which is how much? It's good.
Wait, what?
I'll show you again. You ready? You start on the left. Your first x value is right here at -2. All right, you continue until you get to your point on the right, and the point on the right is an x of 1. All right, for the range, we start at the bottom. What's your smallest y value? -1, good. And then your biggest y value is 6, good. And we're going to put the square brackets on it, so make sure you have square brackets. Don't have parentheses, don't leave it blank, you need those brackets. So you might have, did anybody use inequality notation on these? Remember, inequality notation is what we're going to do with a graph. Last class, some of you started working on my initials for me, and we'll finish that one up later after the check-in. But just to show you what the inequality notation would look like, you don't need it. I just want to show you. So it would be -2 is less than or equal to x, which is less than or equal to 1. Okay? So notice it's the same numbers, it just has the x in the middle and the inequalities. Okay, and I'm going to add them for all of them just so that we have these in our notes. Okay, so we are going to do a short break, and then after the short break, we're going to do a check-in. But if you guys have any questions from your notes that you'd like to go over, let me know so I can help you with those things before. I do suggest you take out the notes that you have from the previous days. Those will help as well. All right.